Hi there, so today we're starting Unit 8, which is all about calculating with fractions, and we're looking today at 8.1, which is ordering fractions. The objectives today are to be able to identify fractions as more than a half or less than a half, and to be able to order fractions. We'll check our prior knowledge as normal first, so we need to be able to know the difference between a numerator and a denominator. So the numerator, the top number of a fraction, is how many you want to have, and the denominator, which is the bottom number in the fraction, is how many the whole is made up of. You should also be able to recognise that a fraction is part of a whole, so 3/4 means 3 out of 4. You should be able to find half of a number, so half of 10 is 5, half of 7 is 3.5 or 3.5. And you should be able to find the lowest common multiple of one or more numbers. So for example, the lowest common multiple of 3 and 7 is 21. And to find that, if you're not sure, you write down your 3 times table and your 7 times table, and you find the smallest number that appears in both times tables. We are going to do a bit of practice with that as we go along. Okay, things you need then today. You need your maths book or some paper to write in, and a pen or a pencil to write with. Okay, we're going to start off then by identifying fractions. We're going to have a look to see if we can work out which fractions are more than a half. This is quite useful if we want to be able to put them in order and things. If we know which ones are more than a half and which ones are less than a half, that's a good starting point for being able to sort them out. So a quick way then to work out if a fraction is more or less than a half is to check if the numerator, that top number, is more than half of the denominator, the bottom number. So let's start with the first one then, so 3/4. So 3/4, to check, we need to see if the top number 3, the numerator, is more than half of the denominator 4. So half of 4 is 2, 3 is more than 2, so our answer is yes, it's more than a half. So our second one then, 2/5. We need to know if 2 is more than half of 5. So we half the 5, so that's 2.5. Is 2 more than 2.5? No. So it must be less than a half. So you can see we're halving that denominator, the bottom number, and then checking if the numerator is bigger than that new number. So for 5/6 then, we need to see if 5 is more than half of 6. Well, half of 6 is 3. 5 is more than 3, so 5/6 is more than a half. 4/7, so we'll check if 4 is more than half of 7. Half of 7 is 3.5. 4 is bigger than 3.5, so yes, it is bigger than a half. And finally our last one, 4/9, is 4 more than half of 9. Half of 9 is 4.5, so 4 is less than half of 9, so no, it is less than a half. So if we want to check if things are more or less than a half, we simply look to see if the numerator is more than half of the denominator. Make sure you're happy with those before we move on. Okay, so your turn then. So we've got some fractions there at the top. You need to write them under the headings more than a half or less than a half. So if you use those as your headings, you can simply list the fractions in the appropriate column. We've then got some reasoning questions, so thinking about what we've talked about in terms of our numerator and our denominator. So I want you to write a fraction larger than a half with a denominator of 17, so remember that's the bottom number is 17, and then to write a fraction that's smaller than a half with a numerator of 5, so that's where the top number is 5. Pause the video, have a go, see if you can do those. Okay, so for our first question there then, so remember the rule was, we said that if the numerator is bigger than half of the denominator, then it's more than half. If it's smaller, then it's less than half. So these are our answers here then. So the ones that are more than half were 7/10, 5/9, 11/20, and 6/11. And the ones that were less than a half are 2/7, 2/5, 9/20, and 4/11. Okay, for our next one then, we wanted to write a fraction larger than a half with a denominator of 17. So that means the number at the bottom needs to be 17. And you could have any numerator that was 9 or greater. So any number at the top, 9 or more with a denominator of 17, would be bigger than a half. For the bottom one then, we want one smaller than a half with a numerator of 5. So you can have any fraction that has a numerator, a top number of 5, and the denominator needs to be 11 or more. So just have a check, make sure you're happy with yours. Okay, next then we're going to have a look at equivalent fractions. Now you will have looked at these before, and this is a bit of a recap for you. So in our diagram then, out of our 4 parts, so 4 equal parts, so fractions, remember, are always talking about equal parts, we've got 3 shaded in. So we would write that as 3 out of 4. So 3/4 is 3 out of 4. 3 parts shaded out of 4 parts in total. Well, what about if I draw some more lines on the diagram? So you can see I've not coloured any more. The amount that was coloured in was the same, but we split it into more equal parts, so like cutting up a pizza. So how many have we got shaded now? 1, 2, 3, 4, 5, 6 out of 7, 8 parts. So we now have 6 out of 8 shaded in, but we didn't shade anymore. So therefore they must be equivalent. The amount of blue that's coloured in is still the same. So how can we create these equivalent fractions? Well, the way to do this is we can look to see, well, what happened to 3 to get 6? To get from 3 to 6, we multiplied it by 2. The denominator, to get from 4 to 8, we've also multiplied by 2. So any time that we multiply the numerator and denominator by the same number, we will get an equivalent fraction. So let's try again. I'm going to split it up into some more this time. Okay, now this time there are 18 blue parts out of 24 parts in total. So still an equivalent fraction. So if I want to get from 6/8 to 18 out of 24, to get from 6 to 18, I would need to multiply by 3. So I must do the same to my denominator and multiply that by 3. So we have to do the same to the numerator and the denominator for them to be equivalent. Okay, that's really important. We can't do different things to each part. Let's have a look at another diagram then. So in this diagram, we've got 2 equal parts shaded out of 3 equal parts. So again, remember the equal sized parts. So 2 out of 3, or 2/3. Let's draw some more lines in. So now again, we didn't colour any more in, but I've now got 6 orange parts out of 9 parts altogether. So they must be equivalent fractions. To get from 2 to 6, we multiplied by 3, and from 3 to 9, we've multiplied by 3. So they're definitely equivalent because we've multiplied the numerator and denominator by the same amount. Let's split it up again. Okay, so this time there are now 24 orange parts out of 36 parts in total. So another equivalent fraction. To go from 6 to 24, we multiplied by 4. And from 9 to 36, we multiplied by 4. So they are definitely equivalent because the numerator and denominator were multiplied by the same number. So that's what's making them equivalent. Okay, this time we've got lots of lines already. So we have got 1, 2, 3, 4, 5, 6, 12, 18 that are coloured in out of 30 parts in total. Now this time we're going to take some of the lines away instead. There we go. So we've now got 6 out of 10 coloured in green. So we've gone the other way. To get from 18 to 6, we would need to divide by 3, and from 30 to 10, we divide by 3. So again, they're still equivalent. Okay, they're still equivalent because we've done the same to the numerator and to the denominator. Let's take away some more lines. Now we've only got 3 green pieces out of 5 pieces altogether. To go from 6/10 to 3/5, to get from 6 to 3, we would divide by 2, and 10 to 5, we've divided by 2. So again, equivalent because we've done the same to the numerator and the denominator. So if we want to create equivalent fractions, we can either multiply the numerator and the denominator by the same number, or we can divide the numerator and denominator by the same number. We usually say when we're doing dividing, making them smaller, we also call this simplifying. So if we're asked to simplify a fraction, it means we divide the numerator and denominator by the same value until we get to the smallest values possible. There are no numbers that fit into 3 and 5, no whole numbers, so I can't divide them any further and make them any simpler. So that's our simplest fraction. Alright, let's have a look at how we can use this to help us then. So we want to create some equivalent fractions by either multiplying or dividing the numerator or the denominator to find the equivalent. So we've been given here 2/5, and we want it to be something over 20. So we need to find out, well, how did we get from 5 to 20? So 20 is bigger than 5, so we must be multiplying. Remember, to be bigger, we're going to multiply. So we need to see how many 5s we need. We need 5 times 4 makes 20. So if 5 times 4 gives us 20 at the bottom, to get an equivalent fraction, we have to multiply by the same value for the numerator. So 2 times 4 would be 8. So our equivalent fraction to 2/5 is 8/20. Our second one, now this time we're missing the denominator here, so we're going to have to go the other way. So let's compare the two that we have for numerators. We have 6 and we have 1. So we've got to go from 6 down to 1. So big number towards a small one, we're going to be dividing. And to get 1, we would have to divide 6 by 6. 6 divided by 6 is 1. Whatever we do to the numerator, we're going to do to the denominator. So we're going to do 12 divided by 6, and that would give us 2. So a half is equal to 6/12. Okay, so if we're going bigger, we're multiplying. If we want to go to the smaller number, we're dividing. So this time here, again, we've got the big numbers here. We want to go to the smaller one because that's where it's missing, but this time we've been given the denominators instead. But the same idea. To get from 21 to 7, well, 7 fits into 21 3 times, so we must have to divide by 3. 21 divided by 3 is 7, so we do the same to the numerator. 9 divided by 3 is 3, so 3/7 is equal to 9/21. Okay, down to the bottom here then. So we've got 2/3, we've got a numerator here of 12, so we'll compare the numerators this time. We go from a small number to a bigger one, so we must be multiplying. To go from 2 to 12, we would have to multiply by 6. 2 times 6 is 12. Do the same to the denominator. 3 times 6 is 18. So 2/3 is 12/18. And our final one then, this time again, we're going from the smaller value to the bigger one. So we're going to compare the two that we have together. So to get from 4 to 40, we would have to multiply it by 10. So we're going to do the same to the numerator. 3 times 10 is 30. So if we want to find an equivalent fraction, and we know either the new numerator or the new denominator, we can find the equivalent fraction by multiplying or dividing the numerator and denominator by the same value. Alright, so now it's your turn then. So just as we did before, make sure you write these down. It's a good idea to draw in the arrows and what you're multiplying or dividing by, just to make sure you're happy with it. So pause the video, have a go now. Okay, so let's look through the answers then. To get from 10 to 20, we've times by 2, so we do 3 times 2 is 6. To go from 10 to 2, we need to divide by 5, so 15 divided by 5 is 3. To go from 18 to 6, we divide by 3, so we'll do 9 divided by 3 is 3. From 4 to 12, we times by 3. 5 times 3 is 15. And from 7 to 28, we times by 4. So 4 times 4 is 16. So hopefully you've drawn in the areas if you need those to help you. Alright, so now that we've looked at equivalent fractions as well, we're going to go back to comparing them. So which is bigger, 3/8 or 5/12? Now a good way to start is to check whether one of them's more than a half or less than a half, because that will instantly tell us. So remember how to check. So we half the denominator, so half of 8 is 4. 3 is smaller than 4, so 3/8 is less than a half. If we do the same for 5/12, half of 12 is 6. 5 is less than 6, so 5/12 is less than a half as well. So unfortunately they're both less than a half, so that doesn't help me to work out which one was bigger. So I need another way to be a bit more accurate, and we can use our equivalent fractions to do that. So by making them equivalent fractions with a common denominator, where the denominator is the same value for both, we'll be able to compare them. So our first step is to look at our 8 and our 12. We need to find the common denominator. So step 1, find the common denominator. 8 and 12 both go into 24. Now this is where our lowest common multiples come in. So if you're not sure, you can write down your 8 times table and your 12 times table. So we take the two denominators and we do the times table for both, and we find the smallest number that's the same in both, the lowest common multiple, and that's going to be what we call our lowest common denominator. So you'll have often heard the term lowest common denominator. So first step is to always find that value. So that's going to be our new denominator. So a denominator of 24 for this one and for this one. And now we're just going to go back to the step we've just done of finding those equivalent fractions. So to get from 8 to 24, we will need to multiply by 3. So remember, whatever we do to the denominator, we do to the numerator. So to get from 3 to our new number, we also multiply by 3. And we get an equivalent fraction of 9/24. So we're doing exactly the same as we did on the previous slide. This time, instead of going across the page from left to right, I'm simply going up and down. Okay, but it's up to you how you want to write it out. We need to do the same with our second fraction. So we're going from 12 to 24. To get from 12 to 24, we would have to multiply by 2. So we do the same to the numerator. 5 times 2 is 10. So these are our equivalent fractions. Final step then, once we have our equivalent fractions, we can simply compare the numerators. So once the denominators are the same, they're both out of 24, then the biggest one is 10, the smallest one is 9. So 10/24 is bigger than 9/24, so that means that it's equivalent. 5/12 must be bigger than 3/8. So when we're comparing fractions, we change them to equivalent fractions with the same denominator, and then we compare the numerators. Once we've compared the numerators, we can decide which of our original fractions are bigger or smaller. Make sure you've paused the video and copied out this example, making sure you've got all of those steps nice and clear. That will really help you with the questions to come. Okay, so now we're going to move on then to putting fractions in order. So we're asked to put the following fractions in ascending order. Ascending means smallest to largest. Now we can see they've all got different denominators, so it's quite hard to compare them at the moment. So we're going to have to change them so that they all have the same denominator. So our first step is to find that lowest common multiple. So I've got to find the lowest common multiple of 6, 4, 8 and 12. If I'm not sure what that is off the top of my head, I can write out my 6 times table, my 4 times table, my 8 times table and my 12 times table and find the smallest number that appears in each one. Now I know that the smallest number that's in all of those times tables is 24. So we're going to have our denominator of 24 for each one. So our first one, 4/6. Well, if I want to change 6 to be the number 24, I would have to times by 4. So if I times the numerator and the denominator by 4, there we go, we get 16 over 24. So I know that I want all the denominators as 24, and we multiplied by 4. To get from 4 to 24, I need to multiply by 6. So again, I have to do that to the numerator as well. 3 times 6 is 18. From 8 to 24, we've multiplied by 3. Do the same to the numerator. 5 times 3 is 15. And from 12 to 24, we've multiplied by 2. Do the same to the numerator. 7 times 2 is 14. So now that we have them all with their common denominator, we were asked to put them in order smallest to largest. So the smallest is the one with the smallest numerator. So that's this one here. 14 is smaller than 15 and 16 and 18. But when we're putting them in order, we have to put the original fraction. So this is my smallest number, so we look up, and that's 7/12. Our next smallest number is 15. So that is 5/8. The next smallest number, 16, is 4/6. And our largest one, 18, is 3/4. So although we've changed them all to a common denominator to help us to compare them, because once the denominators are the same, we can use the numerators to compare. But when we write out our answer, we need to write the original fractions that we started with. So you must make sure you're looking above to find the right one. That's why it's quite important. If you do them down the page in nice columns, it's easy to find the matching pairs. Okay, make sure you've again copied down the example before you move on. Okay, let's do another example. So this time we're also asked to put them in descending order. Descending means largest to smallest. So again, step 1, find the lowest common denominator. So 6, 3, 18 and 9. We find the lowest common multiple of all of those. Now the lowest common multiple is 18. So we're going to have a denominator of 18 for each one. So I always write them just underneath straight away. Now we need to work out how we find those equivalent fractions. So to get from 6 to 18, we times by 3. So we multiply the numerator by 3. So to get from 3 to 18, we multiply by 6. 1 times 6 is 6. To get from 18 to 18, I'm just going to multiply by 1. So 17 times 1 is 17. So if you have the same number already, you don't have to change it. Look, it ends up exactly the same. From 9 to 18, we've multiplied by 2. 2 times 2 is 4. Now this time, remember, we were asked to give largest to smallest. So I'm looking for the biggest numerator. So that's this one here, 17, and that relates to 17/18. So that one is our largest. Our next largest is 6, and that is 1/3. The next largest, 4, so that's 2/9, and our smallest number is the 3, and that's 1/6. So again, we're using our numerators once they have a common denominator to decide which order we put them, just making sure whether we want largest to smallest or smallest to largest, and using the original fractions. So again, if you need to, pause the video and copy down the example. Okay, so now it's your turn then. So you're asked to put the fractions in ascending order, so that's smallest to largest. So for each set, first step, remember, find the lowest common multiple. That's going to be your new denominator. Then find the equivalent fractions with the new denominator, and then you can sort them into order. Pause the video, have a go now. Okay, so let's have a look at the first one then. So the order you should have is a quarter, 3/8, a half, 4/8, and 3/4. And again, a good way to just check these is we've got the half here in the middle. We can check whether these to this side are more than a half. So if we half it, we get 4. Is 4 bigger than 4? But it's the same, so that's exactly a half. So actually these two could be either way around. Okay, if we half 4 here, we get 2. 3 is bigger than 2, so this is definitely more than a half, so it's on the right side. Half of 8 here is 4. 3 is smaller than 4, so this is less than a half. Great, it's in front of it. And half of 4 is 2. 1 is smaller than 2, so this is also less than a half. So it is to the left of it as well. So a good way to finally check is just to see ones that are more than a half should be nearer to the right, ones that are less than a half should be nearer to the left. Our second set then. We've got 2/5, a half, 3/5, 6/10, and 2 out of 2. So remember, 2 out of 2 means 1 whole. If your numerator and your denominator are identical, then that's the same as 1 whole. For C then, we've got 1 out of 3, 5 out of 12, a half, 4 out of 6, and 3 out of 4. And finally for D, we've got a quarter, 1 out of 4, a half, 2/3, 5/6, and 7/8. You'll notice sometimes when I read them, I'll say them as a fraction, and sometimes I'll say them as a number out of a number. Sometimes it helps to think of them as one number out of another number rather than using their names, because only some of the fractions have names. So if I think of a quarter as actually 1 out of 4, then that often helps when we're doing calculating with fractions. So just a different way of saying it, but it means the same thing. Okay, thank you very much for working through that today then. Next lesson we're going to have a look at adding and subtracting fractions. So again, we'll be using our equivalent fractions quite a lot. So make sure if you need to go back through this video again before you move on to the next one.